Alright, hey guys, it's Miss Summers. Today is Thursday, the 27th. So yesterday, you took the baseline, got that all nice and done for me. Today is your last asynchronous day of the week. I'll see y'all tomorrow. But today we are looking at maps. We want to be able to compare longitude and latitude and be able to use those to find a location on the Earth's surface. Alright, so let's start with what maps are. A map is a representation of the Earth's surface. So for example, this is a map of Mecklenburg County, which is, those are our friends that are just south of us. Alright, a map like this is helpful because it has places on it. I know it's kind of hard to read, but we have South Park and Uptown and, what do we got? We got Ovens Auditorium, Charlotte Coliseum. So you could use a map to find somewhere or to make a route. All right, if I want to get from here to there, what roads do I have to take? But maps can tell us other things. So this is a map. Obviously, you're familiar with this shape. Hopefully, this is the United States of America. But this map isn't necessarily about finding a location or like finding an address. This is a map. If I look at the title, just like we would look at the title of a graph, direct normal solar radiation. Basically, how much sunshine do you get a day in a given area? All right, this map might not be helpful for locating something, but it tells us where there's more sunshine. So if I want to get a lot of energy from sun, like if I'm doing like solar panels, I want to go down here where the solar radiation is most concentrated. All right, moving on. So I have a star on this globe. By just looking at the globe, all right, if I was like, all right, here's a globe, could you tell me where the star is exactly? And the answer is, yeah, you can try, but it's not going to be exact. To make it easier, we have a grid system. And this grid system is latitude and longitude, all right? At a given latitude and a given longitude, you're on one spot on the Earth, and that's the spot. There you go, okay? So latitude and longitude is very important when we are navigating, when we're trying to find where something is. All right? So let's take a look at how we divide the Earth up using latitude and longitude. All right, the Earth is divided into something called hemispheres. Now, hemi means half, and obviously sphere is the thing that the Earth is. The Earth is divided into hemispheres. Now, how many hemispheres are there? You might want to say 2, because there's 2 halves to everything, right? But we can divide the Earth up 2 different ways. So there ends up being 4 total hemispheres. The equator is what separates the northern and the southern hemisphere. The equator, which is this purple line right here, is the main line of latitude. That is the main line of latitude. It runs across South America, Africa, a little bit of Asia. But yeah, everything above it is the northern hemisphere. Everything below it is the southern. So we are in the northern hemisphere. Easy enough. The prime meridian is the other line that cuts the world in half. But it divides it into the east, over here on the right-hand side, and the west, which is over here on the left-hand side. So we, again, we being in North America, we are in the western hemisphere and the northern hemisphere. So we're in 2 different hemispheres at the same time, if that makes sense. All right, the prime meridian is our main line of longitude. So when we talk about latitude and longitude, we're comparing where we are compared to the equator or the prime meridian. All right, so let's take a little closer look at latitude. There we go. This is where people get confused. Lines of latitude run side to side. They run east to west. But when we measure, you are either north or south of a line of latitude. You are either above the line or below it. Okay? So, for example, let me give you an example. Lake Norman, where we are, is about 33 degrees north of the equator. So the equator runs east to west. We are above it. We are north of it. It's measured 0 to 90 degrees. So it's at 0 at the equator, 90 degrees up here, 90 degrees down here, 90 plus 90 is a total of 180 degrees. Think of latitude like a ladder. You go up the ladder or down the ladder, so you can either be north or south. Write this down and put a big old star next to it because we will come back to this idea many a times over. As latitude increases, temperature decreases. That's kind of the big idea when it comes to climate. All right, it's not the only factor, but latitude is the most important factor. So if it's wintertime and you're like, you know what, I want to go somewhere warm, you would pick somewhere near the equator, near this line, right here, around South America, the northern part of South America, Central Africa, Southeast Asia, somewhere like that. If you think about places that are cold all the time, maybe like Greenland, Antarctica, those are at very high latitudes. So high latitudes, low temperature. Low latitudes, high temperature. Opposite. Cool beans. And again, there's my equator. There's the furthest pole. All right, longitude. It's important to note, lines of latitude are parallel. They do not cross each other. Lines of longitude meet up. All right, and again, this is kind of confusing. Longitudes run from north to south, like this red line here, that's the prime meridian, but you are either on the right side of the line or the left side of the line. You're either to the east or to the west. To the east, to the west. To the east, to the west. All right, it is measured from 0 to 180 degrees. So it would be 180 on the opposite side of the prime meridian each way. 180 times 2 is 360, and that's how many degrees are in a circle because the Earth is a big round thing. That makes sense. Longitude, think of them as the long lines. Whoops. Again, they meet at the poles. They don't affect climate. All right, if I look at like the prime meridian, all right, the prime meridian runs through London, England, which is kind of like a moderate climate. Like, it's not super hot. It gets kind of chilly, but not like crazy cold. But the prime meridian also runs through like Western Africa, which is really hot like most of the time. And then it also runs through the South Pole, which is really cold all the time. So longitude does not change climate. Latitude changes climate. All right, now let's think and practice identifying coordinates using latitude and longitude. So when we do this, we are going to, if I want to tell somebody where I am, I'm going to use two numbers, a number to represent latitude and a number to represent longitude. So let's look at A first because A is right here. I'm going to do latitude first. When I look for latitude, I'm going to go to the equator. And then I'm going to think, okay, is my place above or below the equator? This letter A is below, so that means it's to the south. This A is 20 degrees south of the equator, so I would put 20 degrees south. And I could just put an S for south. All right? Now I'm going to do longitude. Well, I'm going to go to my main line of longitude, which is the prime meridian, which is here. The prime meridian, am I to the left or to the right? I'm on the right-hand side, so this is east. And then I'm going to go over, and I'm going to trace up. And again, these lines curve. This particular projection is called a Robinson projection. I really like it. It's pretty okay. This is 100 degrees east of the prime meridian. So A is 20 degrees south, 100 degrees east. You have to put the direction just like you use a unit to make something make sense. Because if I just said 20 and 100, that could be over here. Or it could be over here. Or it could be over here. All right. So that is an example of that. So let's do a couple of these. I know we didn't do all those, but let's do a couple of these together. A. So again, I'm going to do latitude first, then longitude. So there's the equator. I have to go up, so that's north. And I go over, that's 45 degrees. So it's going to be 45 degrees north. Now for longitude, here's my prime meridian. In the center here is to the left, so this is west. And I'm going to trace up. I'm going to follow this line. It's kind of hard to. It's in between 120 and 90, which is like 105. Quick math. So 45 degrees north, 105 degrees west, as I have there. All right, now let's look at B. So again, I go latitude first, go to the equator. This is to the north of the equator. I have to go up. That's at 30 degrees north. That's my latitude. My prime meridian is over here. It's to the left. That's the west. This is, I think that's 90 degrees, I'm pretty sure. So 30 degrees north, 90 degrees west. Now, having these two, remember what I said about latitude. The higher your latitude, the colder your climate. So I would expect A to have colder temperatures than B. And that makes sense. B is like Louisiana, Gulf of Mexico area. It's pretty warm most of the time. A is like almost in Canada. It's usually kind of cool there. All right. Letter C. This one's interesting. Look at where it is on the equator. Okay. This is basically on the equator. Let's just pretend it's there. If it's on the equator, I don't need a direction because I'm not north of it, nor am I south of it. So it's just going to be 0 degrees. Now I go to my prime meridian for my longitude. It's to the left, to the west. This is 45 degrees because that's in between 30 and 60. I took 60 minus 30 and then cut it in half, 15. So 0 degrees, 45 west. I'm going to give you a second to do D, E, and F. You can pause the video. Okay, and we're back. Let's double check our answers. D is 15 degrees south. It's below the equator, but because it's on the prime meridian, I don't need a direction east or west. E is 30 degrees north, 90 degrees east. And F, is 45 degrees south, 165 degrees east. Now I want you to take a look at B and E. So here's B, and you're kind of where Louisiana is, and E is kind of like northern India-ish, kind of Himalayan mountain range-ish. All right, these are the same numbers, but they're two different places because I have two different directions. One is to the west of the prime meridian, where B is. One is to the east. So directions are important. You can't just have a number. All right, so that concludes these notes for today. So hopefully you've taken away how to find a point using latitude and longitude, how to write latitude and longitude, how latitude changes climate, and why maps are helpful. All right, so you do have an activity to complete on Canvas. If you have any questions, you're always free to email me. If you think about a question later, write it down so we can talk about it tomorrow when we go over this in our synchronous lesson. So y'all have a super great day. Make sure you get your assignment done and turned in. I'll talk to you soon.